On section 6.2, we're going to learn additional properties of parallelograms. Theorem 6.1. Theorem 6.1 states opposite sides of a parallelogram are congruent. For example, if we have parallelogram A, B, C, D, we know from the previous section, by definition, that opposite sides are parallel. This adds more information to the definition of a parallelogram, this being that opposite sides are congruent. Therefore, segment AB is congruent to segment DC. Segment AD is congruent to segment BC. That does not mean that all four sides are congruent, just the opposite sides are congruent. Theorem 6.2. Opposite angles of the parallelogram are congruent. Therefore, I know that angle D is congruent to angle B. Angle A is congruent to angle C. Again, not that all the angles are congruent, just the opposite angles. Let's look at an example that uses those two theorems. Given parallelogram ABCD, find the measure of AD and BC, and the measure of angle B and the measure of angle D. From the previous theorem 6.1, I know that opposite sides of a parallelogram are congruent. Therefore, I can set up the equation 6m minus 8 equals 2m plus 16. Solving that equation, subtract 2m on both sides, I get 4m. Add 8 on both sides, I get 24. Divide by 4, m equals 6. But this does not solve my problem because I need to find the measure of AD and BC. Therefore, I need to substitute. When I substitute 6 into the expression, 2 times 6 is 12, plus 16 is 28. Therefore, since BC is 28, so is AD. Now, I need to determine the measure of the angles. But from theorem 6.2, I know that these opposite angles are congruent. Therefore, set up the equation 5y minus 6 equals 2y plus 12. Solve the equation, subtract 2y, I get 3y. Add 6, I get 18. Divide by 3, I get y equal to 6. And it's just a coincidence that these two variables have the same value. But I need to find the measure of the angle, so I substitute back in 2y. 2 times 6 is 12. 12 plus 12 is 24. Therefore, angle D is 24 degrees. Angle B is 24 degrees. Theorem 6.3. The diagonals of a parallelogram are congruent. Given parallelogram A, B, C, D, I'm given diagonals being AC and segment DB. Recall, a diagonal is a segment that intersects the vertices of the opposite angles. And in this situation, theorem 6.3 states that the diagonals are being bisected. Therefore, segment AM is congruent to MC, and DM is congruent to MB. Let's take a look at an example that uses theorem 6.3. We're given parallelogram PQRS. We want to find the lengths of the diagonals. Here I know that the diagonals are bisected. Therefore, we have these two segments being congruent and these two segments being congruent. Notice that the expressions have two different variables. Therefore, I have to use a system of equations to solve for that situation. So what I'm going to do is let A equal B plus 2. That is using theorem 6.3. The diagonals bisect. So here, this segment is congruent to that segment. That sets up this equation. I also know the other equation, B plus 10 equals 2A minus 8. To solve this system of equations, I'm going to use substitution. I already know what A is equal to. A is equal to the expression B plus 2. So I'm going to substitute this expression in for A into this equation. B plus 10 equals 2 times A is B plus 2 minus 8. Now we just simplify both sides and then solve the equation. B plus 10 equals, distribute, I get 2b plus 4 minus 8. B plus 10 equals 2b minus 4. Let's subtract b on both sides. I'm going to get b and add 4 to both sides. I get 14. So the value of b is 14. Let's substitute that back into our first equation and find the value of a. So when I do that, I'm going to get a equals 14 plus 2, which is 16. But our question asks to determine the length of the diagonals. Therefore, I have to substitute these values back into the expression. So when I substitute 14 into this expression, I'm going to get 14 plus 10, which is 24. Therefore, this entire segment is 24. But I can verify that by substituting 16 times 2 is 32. 32 minus 8 is 24. And the length of diagonal QS is equal to 48. Now we have to find the length of the other diagonal. Here, A is 16. B is 14 plus 2, which, of course, we should know is 16. And the length of diagonal PR is equal to 32. Theorem 6.4. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Here we're given 3 parallel lines. The first transversal has 2 segments that are created by these parallel lines. Segment AB is congruent to segment BC. If this is the case, then this theorem tells us that no matter what transversal intersects through these 3 parallel lines, they cut off congruent segments. Therefore, since AB is congruent to BC from this transversal, I am guaranteed that segment DE is congruent to segment EF. Let's look at some examples related to those theorems. Given parallelogram ABCD, find the value of x in the diagram, then find the measure of angle A. Here we're given a parallelogram, and in a parallelogram, I know that opposite angles are congruent. So angle A is congruent to angle C, and I know that angle D is congruent to angle B. Therefore, I can set up the equation 135 minus x equals x plus 15. Solve the equation, add x to both sides, I get 2x. Subtract 15 on both sides, I get 120. When I divide by 2, I get x equal to 60. We found the value of x. That's part of our problem. Now what we want to do is find the measure of angle A. Let's substitute 60 back into our problem. X plus 15, 60 plus 15 is 75. That's the measure of angle B. And I know that the measure of angle B is congruent to angle D, which is also 75 degrees. But I need to find the measure of angle A. By the definition of a parallelogram, I know that opposite sides are parallel. And from our theorem about same-side interior angles, I know that if 2 parallel lines are cut by a transversal, then same-side interior angles are supplemental. Therefore, 75 from 180 leaves me the measure of angle A equal to 105 degrees. Our next example, we want to find the value of x and y in parallelogram KLMN. In this parallelogram, I'm given diagonals KM and NL. We know that they bisect, and that makes each one of these segments congruent. Therefore, I can set up equations. Since these 2 segments are congruent, x equals 7y minus 16. And this equation, because these 2 segments are congruent, are going to be 5y equals 2x plus 5. This is a system of equations because I have 2 equations with 2 unknowns. Since I have a variable already equal to the other expression, I can just use the substitution method. In other words, I'm going to use this equation, and in place of x, I'm going to use 7y minus 16. Therefore, 5y equals 2. Instead of x, 7y minus 16 plus 5. Simplify. 5y equals 14y when I distribute, minus 32 plus 5. Simplifying again, 5y equals 14y minus 32 plus 5 is a negative 27. Let's subtract 14y on both sides. When I do that, I'll get a negative 9y equals a negative 27. Therefore, when I divide by a -9, y equals 3. Let's find the other value, which is x. Let's substitute y into this expression. X equals 7 times 3 is going to give me 21, and 21 minus 16 is going to give me 5. I found the value of x and y, and if I need to, I could substitute in to find all my links, but all they asked me for in this problem is to find the value of x and y. Next, they want us to find the measure of angle R. Recall from a previous theorem, we know if I'm given a parallelogram that the opposite angles are congruent. Therefore, P is congruent to R, and angle Q is congruent to angle S. Given these two expressions for those two known congruent angles, I can set up an equation. 6y plus 4 is equal to 3y plus 37. Solving the equation, subtract 3 on both sides, I get 3y. Subtract 4, I get 33. Divide by 3, I get y equal to 11. Here they want us to find the value of angle R, so I need to substitute to find our two known angles. So y is 11. When I substitute, 6 times 11 is 66. 66 plus 4 gives me 70 for the measure of angle Q and angle S. But since this is a parallelogram, by definition, opposite sides are parallel. And a previous theorem, if I'm given two parallel lines cut by a transversal, then same side interior angles must be supplementary. Knowing that the measure of angle Q is 70 degrees, the measure of angle R must be 70 from 180, 110 degrees. Our last example, they want us to use the information in the diagram to find the measure of EH. And on our previous theorem, if given 3 or more parallel lines, and if they cut off congruent segments on one transversal, it cuts off congruent segments on all transversals. Therefore, it's given here that DC is 4, CB is 4, DA is 4. Therefore, I know these are all congruent segments. So every transversal through these parallel lines will cut off congruent segments. So I know that HG is congruent to GF, which is congruent to FE. And therefore, the measure of each of those segments has to be 4.2. And they want us to find the measure of segment EH. EH is these three segments added together. Therefore, 4.2 plus 4.2 plus 4.2 is going to give me EH equal to 12.6.